Computer Science Course 101, Database Management. We will explain to you how the data is managed, database managed in computers. Okay, this is actually a college course in computer science. First of all, the data is brought into the memory, and memory has an address. So it looks like address is 101, 102, so and so, 901, 902. And where the data come from? Well, computers architecture class will explain to you there's a storage, which is usually hard disk, and management between storage and data memory is the subject for computer architect class. Okay, now the data is brought in and it's randomly stored in the memory. So what's happened is, say you have a data like cat, dog. Okay, do you have a data here, the dog? Then you have to search one by one, and here I found it. Okay, that's no big deal for computer if the data is like 100 or so, but when it comes to million or 10 million, it gets slow to find anything. So what you do is usually you sort it out. That means by number or alphabet. And if you say, do you have a dog? You check the one in the middle. It's called bisection search, right? And well, it's not. This is a dog, is a D, so it should be before that. Then you go in this range, the middle, and find it again. If not, you go to the middle. So bisection, you do the search. This search algorithm reduce the search time tremendously. Well, the number of data, and later it's going to come out. It's only log is a search time. So what's happened is the search time very short. When it's sorted in the beginning and it's fixed, never change, then you bring it from hard disk and place in the memory and do the search. It's no problem. But when data has to be changed, for example, I have to insert here like cotton between C and D. So what do? You move entire data, shift to one, and put the cotton in the middle. It's not efficient, and that's why we use linear link. Linear link is each memory location has link address. Okay, and what's happened is when the new one come in from here, we point this memory address, right? And here the link to here. So in the illustration, you have a data and the link, and it's pointing to the next data 2, and link this way. Now you have to insert something here between. So what you do is you delete this and you point this guy instead, and this guy point this guy, so data can be inserted easily. Okay, so location to insert is go by binary search, whatever, and insert it, so you can organize the data always sorted without much movement of the data. It's just the link. Just change this link and this link, then you got it, right? But the linear link is not that efficient too. So that's why computer scientists invented the binary tree. What's binary tree? So here's the pictures. Okay, what's happened is, here's the nodes. Nodes has data, and the link data 1 and link data 2. Link data 2 is to point right side, and link data 1 is point to the left side. So this is a set. Okay, each node has that. And what's happened is the new data come in. You compare with this data. If it's the it should be placed after this data, then go to the right. If it should be placed before this data, then place left. The right, left. So it's each decision divided into right or left. And if this is the new data, then we place here. Or if it's going to be here and replace this one, then the tree grows. Okay. Now this one is like bisection search. You need only n steps of search for 2 to the n data. For example, 2 to the 20 is like a 485 million data. So you need only 20 steps for search, which is no big deal on the computer. And that's why computer search is very fast. They grow the binary tree to store the data and organize it. It's called data management. Okay? Now, the problem with binary tree is, if you look at this, you have a data and you have 2 link address. So you waste a lot of memory, and management of this link is going to cost you. The cost increase. Search time dramatically decrease, but the cost increase. So it's a trade-off of search time versus cost of memory. So the compromise is a linked table. Instead of having just single data, you can have list of table, right? So each node has some amount of memory, then you link together. So this gonna reduce the cost, even the large data. So that's the kind of technique we use. There is some special case like some game and other special database use network. Network is like you have this, and depending on certain algorithm, it's a branch out, and it may come back here again. And this gonna be very difficult for search algorithm, because it may go around and you may never find the one you need. Okay, so this is a very special design, custom design. Database for specific purpose, like a game program and stuff. Okay, so there's a few sorting technique, how you sort it, right? Say if you have in the beginning data is like, okay, 265 and 270, and this is the memory, and 101 and 150, so on so. Now you try to sort this out. What you do is, in order of small number, you check each one, and if you find a smaller number than any of this, then you move this up. So it's gonna be 101, and was it 270? Okay, so it will move as if this is a bubble. The bubble move up, and you go again from top, and this bubble move up again. 265 go down, and 100 comes here. Okay, you keep repeating this until it's sorted. That's a bubble sort. It's not that efficient, but it's an educational value. So the sort by linear search, we already talked about it. This linear is very long linear, like millions of link. For example, this link become very long, then sorting from top is going to be very costly in terms of searching time. It's used in link data, linear link data, so you don't have a choice. But if binary, it's very, or linear link data, you can use bisection. But binary trees already has a built-in mechanism for sorting and searching. So this is pretty much accepted technique for database management. And other than that, there's a data buffer. FIFO, LIFO is a first in, first out. The last in, first out. This is used for temporary storage. For example, the data come in, and the first came in is gonna be stored here, and it's just a buffer, okay? And the first one is gonna go out. That's FIFO. And when you have like a bucket of data, and first in, last in goes out first, like a stack address. Okay, because when something nested, this kind of structure use LIFO, because the last thing goes out first, last thing goes out first, and next one goes out first. So it's like in the bucket that you store by layer. Okay, the FIFO is like first in, first out. This is the first in. The old one goes out first. Okay, and the write through and the write back. This is like used in the cache. So what's happened is, when you have a large database, okay, you get some data, but if you know it's going to be used again by user, then you leave it in a cache. So you don't have to go search the large database again, because the small size cache keeps most frequently used data. And what's happened is, when user put the data here, okay, and write the data and read it again, that's fine for the single user. But when you have multiple users come in and check the data, then this new user may use written data, or sometimes, there is some synchro problem. You may know it may not finding. It may not be finding this data. So what you do is, as soon as the new data is written into the cache, you write into the main database. Okay, that's called write through. Okay, and instead you leave it for a while, and later, depending on the algorithm, you write it back. That's called write back. And the write back is more efficient, but has a risk of synchronization risk among the users, and also the power failures, all kind of failure problem. The write through is safer, but it's reduced the performance of the cache a little bit. Okay, so that's a kind of technique for the data management. This is for data buffer. Okay, so that's pretty much everything about database, and there's new database management method is coming up. in the new computer architectures, but basically it's extension of those basic management ideas. So I hope you enjoy these videos and check other videos we have. Thank you for listening.